everyone, welcome to our channel CodeChef. This is Kusmulata Bhatt and today we are going to solve the problem Mayor Ram and Portals, which is the slightly higher version of its previous one. So the difficulty level of this problem is simple and it is an observation based problem. So now let's understand the problem statement. There are n portals in a machine that are numbered from 1 to 3 to n, and each portal of this has some value associated with it which is also in the range of 1 to n, and every value is distinct in these portal overall. That is, the portal is going to have a permutation of values from 1 to n. So this is what is going to happen there. Now there is also one thing here, that the portal having value of px is linked to the portal having value of x plus 1 or x minus 1. That is, p of I will be linked to p of j. We can move from p of I to p of j if p of I has x value and p of j has either x plus 1 or x minus 1 value. That is, the absolute difference between the value of p of I and p of j is equal to 1. And the cost of moving from p of I to p of j portal will be I minus j. That is the difference between the positions of these two portals. So now we are going to have Q queries in which we will be asked that what will be the minimum cost to reach to the portal P of I to P of j. So this is what we will be asked, and we have to follow the path, the connected path which is defined by this x and x plus 1 or x minus 1 thing. So this path we have to follow, that is, we have to follow a sequence such that when we are going to some other portal, if p of j is not directly connected, then we need to follow some other sequence, and in every sequence we are making sure that the adjacent two portals are having the absolute difference of value 1 and the cost is minimized. And what is the cost when we are moving from p of I to p of j? Then it is simply the difference between the two portal numbers. So let's understand it better by taking the sample input, but let's first understand the input format of this problem. So we are going to have n and q variable. There are no test cases. There is only single test case in this problem. So here n is the number of portals we are going to have and q is the number of queries. Then for the n value, we have n integers v1, v2 to vn, which are the values that are associated with the portal. Now each queue line is going to have queries of two types, in which one is going to have source and destination. So this is what this indicates, that we have to go to the p source to p destination portal, and these source has some v values associated with it. Now for the constraints, we have n and q value lying in the range of 1 and 10 to the power 5, and source and destination value is going to lie in the range of 1 and n only. So this is our constraints. Now let's look at the sample input to have a better understanding of the problem. So here n is 4 and q is 2, and we have 1, 3, 2, 4 as the values associated with every portal. So this is the numbering of the portal numbers. Now for the first query, we have to move to P1 portal to P2. Now P1 is having 1 value and P2 is having 3 value. So how we will be moving to P1 to P3? So definitely for moving to P1 to P3, we have to take help of 2. So in this case, the cost of going from 1 to 2 will be P1 minus 3, because 2 is at the portal number 3, and the cost of going from P of I to P of j is simply the difference between the number of two portals. So in this case it is going to be 1, and from moving to 2 to 3 we are going to have the difference of 1 because it is at P3 and it is at P2. So the difference between the two is 1. here for moving from 1 to 2, it was 1 minus 3. And absolute value of this, so it will be 2 plus 1 equal to 3. So this is what the output for the first sample, for the first query. Now let's look at the second query. So we are asked to move from P4 to P2. So P4 has value 4 associated with it and P2 has value 3 associated with it. So we can directly move from 4 to 3 and the cost of it will be absolute difference of 4 and 2. So this is going to be 2. So here the sample output is 3, 2, which is same as the sample output we are given with. So now let's understand the problem well. So one thing is clear here, that if we have to go from some portal P of source to P of destination, so we are going to follow the connected path, and this connected path is defined by the values difference, that is x is connected to some other portal only when the difference between the two values is going to be 1. So for the given x, it is only going to be connected with x minus 1 or x plus 1. And it is sure that there will be only one candidate of x minus 1 if it is existing, because this is the permutation. And also we have to make notice that for the value 1, we do not have 0. So in this case, it will be only get connected to 2. And also for the case of n, we are only getting connected to n minus 1 but not to n plus 1. So now let's focus on the thing that we can have, let's say P source has some value as x and P destination has some value y. So we have to reach from x to y. We know that if x is less than y, then there is no point to go on left. So we will be going to x plus 1. And then from x plus 1 also, if it is not equal to y, then there is no point to going back to x, because it will only increase our cost. So we will be moving to x plus 2. So we will be moving in positive direction only. There is only going to be one shortest path having the minimum cost, that will be increasing x until it reaches y. And in the mid, we will be updating the cost as the number of portal the value will be associated with. Let's understand it better. Let's say we have to move from 1 to 5. So in this case, we are sure that we have to first get to the value, to the portal having value 2, then 3, then 4 and then 5. Then let's say it is at portal I, it is at portal J, it is at K, it is at L and it is at M. So we will be simply adding I minus J, then J minus K, then K minus L and then L minus M to our answer. So this will simply get added. So this is what our minimum cost will look like when we will be moving x to y such that x is less than y. Now, if we have to move from y to x, so this would have been case when x would have been greater than y. Let's say in this case, x is greater than y. X is still smaller than y. So in this case also, what we can do is we can follow the back thing. That is, from y we will be subtracting y unless it becomes x. So this is what we would have been follow, and in the mid we will be adding the answer as it will be coming. So this is what we are going to do. So for every query, we will be simply moving value by value. So let's say we have source value as 1 and we have to reach the portal 1 to portal 3 and it is having value, let's say we have in permutation as 51423. This is the portal number. So now in this case we have to reach to portal 1 to 5. So portal 1 is having value 5 and portal 5 is having value 3. So we will be first going to 4. So we will look up that which portal this 4 value is associated. So in this case, it is associated with P3 and 5 was associated with P1. So in this case, the cost of moving from 5 to 4 will be 2. And then we will be moving to 3, which is our absolute destination. So here it is associated with P5 and we are coming to P5 from P4. So the cost here will be 2. So it will have the minimum cost of 4 in order to reach to the portal number 1 to portal number 5. So now how we will be implementing it effectively? So what we have to do here is, first thing is, if we have some x value, we know that we will be decrementing or incrementing it as per the need of the destination. And we have to make sure that while we are incrementing the value, we are also getting it indexed. So we need some way so that we are mapping these value with their index. So we can use a map or an array for this purpose. So here, let's say we have an array as, let's say idx, or any name of the array we can take. So in this, the ith variable is giving us the position of I, or we can say the portal having value I, number of portal basically. So idx of I is simply giving us the number of portal having value I. So here idx of 4 in this case will be giving us 3 because portal 3 is having value 4. Similarly, idx of 3 will be giving us 5 because portal 5 is having value 3. So this is how we are constructing this vector idx, this array idx. So how we will be constructing it? We will be simply traversing the values of portal, and we will be simply updating the index of every value of portal as I by going to the pith position of this idx array. So this pi is simply representing us the value of portal I, and we are going to that position in the index, and then we are updating its index there. So yes, this is one of the steps which we are following. Now we cannot just move from x to x plus 1 to x plus 2 to y, or x to x minus 1, x minus 2 to y. We cannot just simply do it, because in the worst case we can have x value as 1 and y value as n, and then for the q carries we are taking n such steps. So this will give us TLE. So we have to think something to optimize this way. So what we can do here is we can take the reference point. Now let's say we have a reference point as 1, that is we are moving from the portal having value 1, and then we are moving to some portal having value x, and then we also know that what is the cost from this portal having value 1 to moving to y. That is, let's understand it better by taking the example. Let's say we have a point O, A and B. We know the distance between O and A as x, and we know the distance between O and B by y. So we are sure that the distance between A and B is going to be y minus x. So this is what we are going to do here. We are taking 1 as the reference point here. At this point we have taken 0 as the reference point. But here we are taking 1 as the reference point, and we are finding that how much time it will take to transfer an object from 1 to x. So it will be given by t of x, and then we are also finding that how much time it will take to get to y from 1. And then we will simply subtract the both values. So to get the time we will be taking to reach from the index from the value x to value y. So this is what we will be doing. So from every query, we will be provided with the portal number source to destination. So we will be first assessing what is the value that is present at source. Let's say the value present at source is x and the value present at destination is y. And let's say we have also a vector which is giving us t of I value, of which is giving us the time taken from 1 to I to transfer an object. So this is what is given by t of I. So in this case, a simple answer will be, this is the value which is at source portal and destination portal. X is the value which is at the source portal, and y is the value which is associated with destination portal. So the difference here is going to be t of x minus t of y. So this is what our answer is going to be for every query. For the given source and destination, we are simply going to print the absolute difference of T of P of source minus T of P of destination. So this is just the constant time operation for every query, provided we have constructed this T array and IDX array simply. So let's see how we will construct this T array. So here we know that for reaching to the portal having value 1, we are going to have 0 cost, because from getting to the portal 1, we are coming from nowhere. We are taking 1 as the reference, so we will be initializing it with 0. Now, for moving to the portal having value 2, we will be just subtracting the position, the number of portal which is having value 2 to the number of portal which is having value 1. That is, for calculating the value of T of 2, we will be adding the cost which is there to get to the portal 1, and we will be subtracting the position of the portal having, we will be subtracting the portal number having value 2 from the portal number having value 1. That is, we will be subtracting both of the portals which are having these respective values. So here we will be taking the difference of IDX of 2 minus IDX of 1. So let's say 1 is present at 3 position and 2 is present at 1 position. So here its cost will be T of 1 plus 2, that is 2. So this is what we will be doing. What for the ith, for getting to the ith portal, we will see that what is the cost to getting to the I minus 1th portal. So this I minus 1 is basically value to get to the portal having value I minus 1, and then we will be simply subtracting the number of portal having those I minus 1 and I value. So we will be doing the subtraction of IDX I minus 1 and IDX I. So this is how we are going to construct our T array. So the time complexity for this problem is going to be O of n plus q, where n is the total number of portals we are having and q is the total number of queries. So now let's have a look on the C++ code for the same. So here I am taking the input of n and q value, and then I am declaring a vector of p, t and idx, where p vector is going to store the value associated with the ith portal and t value is going to store the cost which will be required to get to the ith value from the portal having value 1, and then idx is simply storing the index of the port. That is, for the ith index, it will be storing the number of portal which is having that ith value. Then we are simply taking the input of the portal value and updating its index as I at the particular index in IDX vector. And then we are constructing the T vector as T of I equal to T of I minus 1 plus the absolute difference between the positions, between the numbers of the portals which are having these values. And then for every query, we are taking the input of source and destination, and we are simply printing the time it will be required to get there using 1 as the reference. So P destination is giving us the value which is present at the destination portal, and P source is giving us the value which is present at the source portal, and then we are taking the cost which will be required to get from destination to portal. Now let's check whether it passes the sample input first. So we are running it on it. So yes, it is giving us the output of 3 and 2. Now let's submit it and see whether it passes all of the test cases or not. And one thing we have to make sure here that we are defining our int as long. What I can do here also is I could have explicitly used long, but I have declared my int as long for all of the cases. because we can have overflow problem here. So yes, it is giving us the status of correct answer. Let's have a look on the Python code. So here again I'm taking the input of n and q value. Then I'm taking the input of all values associated with the portals. Then here instead of array I have declared a dictionary, and I am storing the index of every value of the portal here in this dictionary, and make sure of the indexing that in the array all values are stored in the zero base function, but here I am simply converting it to one base. That is, if in the array 1 is present at the second index, then in the dictionary I am storing it index as the 3, and here I am using t list again so as to store the time it will be taking to get to the position to the value I from the portal having value 1. So here for every I from 1 2 to n, I am simply appending absolute of dictionary I minus dictionary I minus 1. So this is what giving us the cost to get from the portal having value I minus 1 to the portal having value I, and I'm simply adding the previous value, that is how much cost it will be required to get to the portal having value I minus 1. Then for every query I'm taking the input of x and y value, and then here I'm decrementing its value by 1 and simply printing the result here. So in this case, I have used zero-based indexing. I have introduced zero-based indexing also. So we have to make sure accordingly for the same that we are doing the operations correctly by taking account in the fashion we have stored its value. So let's run it on the sample test cases and submit it and check whether it passes all of the cases or not. So yes, it is giving us the status of correct answer. So that's it for the video guys. Thanks for watching.